I'm going to go over the test wizard practice test that I assigned to you guys. It's very similar to the actual test that you will be taking. So I wanted to debrief this assignment, and I will be happy to answer any further questions you have within this test. So let's just jump right into it. I'm going to start with question 1. It says, given the balanced equation, which type of reaction is represented by this equation? So this is types of reaction. If you remember your types of reactions, we start with a compound. We have a reactant that's similar to A, B, and it gets broken down into A plus B. So this is a decomposition reaction. Question 2. What is the gram formula mass of ammonium sulfate? So ammonium sulfate, to find the molar mass, we need to find out how much each of these elements contains in the compound weighs. So we do that, we use our periodic table. We see that we have 2 nitrogen, subscript 2 tells me that there's 2 nitrogen. We have 8 hydrogen, because 4 times 2 is 8. We have sulfur, and we have 4 oxygen. If you find the masses for all of these and add them up, you'll find that this compound has a molar mass, or a gram formula mass, of 132 grams. Question 3 is asking which compound has the greatest percent composition by mass of sulfur. Okay, so if you look closely, you'll see that all of these metals that sulfur is bonded to are group 2 metals, right? Sulfur has a mass of 32, and I'm going to find the masses for the metals. The metals, barium is 137, and calcium is 40, magnesium is 24, and strontium is 88. I'm going to round that, right? So to find the percent composition is given by the formula part over whole times 100. Okay? The part is the sulfur, that's the percent we're looking for, and the whole is the sum of everything in the compound, the molar mass. So if we were to add up sulfur with barium, sulfur with calcium, sulfur with magnesium, sulfur with strontium, you would see the one that gives you the greatest percent would be magnesium sulfide. Question 4 is a conversion question. We're asking what is the total mass in grams of 0.75 moles of SO2. So to do this, we need to set up a dimensional analysis problem, and we're going to need a conversion factor. We're going to need the molar mass of SO2. So SO2, we have S is 32, and oxygen, 2 of them, is 16 times 2, another 32. So the conversion factor we're going to use is that SO2 has a molar mass of 64 grams per mole. Okay, we're going to hold on to this information and set up our dimensional analysis. So the question is asking to find the total mass in grams. So how many grams is equal to 0.75 moles? Okay, now conversion factor, we have to put moles on the bottom so that moles can cancel moles, and we're going to put grams on the top. I have 64 grams for every mole, and if we put this in our calculator and multiply the top, we have 0.75 times 64, and that gives us an answer of 48 grams. Our answer is D. Question 5. What is the percent composition by mass of aluminum in aluminum sulfate? All right, so this one gives us the molar mass. this one gives us the molar mass. When we are given the molar mass, we use that number. We do not have to calculate it on our own. The only thing that we need to know and use our periodic table to find is the atomic mass of aluminum. And aluminum has an atomic mass of roughly 27. So it's part over whole times 100. Aluminum is our part. The molar mass is our whole. So we have 27 over 342 times 100. I'm going to put that in the calculator. And we're going to get an answer of 7.89%. Answer A. Okay. 6. What is the gram molecular mass of a compound if 5 moles of the compound has a mass of 100 grams? Okay, this is another dimensional analysis problem, but it's asking for the gram molecular mass, which is usually grams per mole. So how do we set this up? Well, all of our choices are giving us grams, so we know we're looking for grams. How many grams? And we're looking for how many grams are in 1 mole. We are looking to find out how many grams are in 1 mole because we're looking for grams per mole. So if we use this setup, we can then use the conversion factor that's kind of given to us in this question. It's telling us that 5 moles is equal to 100 grams. So the question, going back to the dimensional analysis, how many grams are in 1 mole? Conversion factor. On the bottom, I need to cancel moles. So I put moles on the bottom, moles cancel moles, and I'm going to put grams on the top. I know that 5 moles is equal to 100 grams. So now I can put this in my calculator. I could say 1 times 100, of course, is 100, and 100 divided by 5 is going to give us 20. The molar mass is 20 grams in every 1 mole. Okay. Question 7. During all chemical reactions, mass, energy, and charge are all, well, this has to deal with the law of conservation. Law of conservation. This was a big theme in the stoichiometry unit, so I do hope you remember that mass, energy, and charge are all conserved. Okay, question 8. In a sample of solid barium nitrate, the ratio of barium ions to nitrate ions is, okay, so we're going to look at our subscripts here. Here is our nitrate, and here is our barium. Barium does not have a subscript, so barium is 1. And nitrate, that too, tells us there are 2 nitrates, so the ratio is 1 to 2. Question 9. Given the balanced equation, what is the total number of moles of carbon that must react completely to produce 2 moles of C2H6? Okay, so we're going to use molar ratios here and set up a problem so that we can solve for this across moles to moles. So I have 2 moles, I have 2 moles of carbon, 3 moles of H2, and 1 mole of C2H6. So those are the molar ratios that we are going to use in our dimensional analysis setup. So the question is asking, what is the total number of moles of carbon? How many moles of carbon that are needed to completely react to produce 2 moles of C2H6? Okay. Now let's use the relationship between the moles from the balanced equation. We have moles of C2H6 on the bottom so that they can cancel over here. And we're going to use that to get to our moles of carbon. So it takes me 2 moles of carbon and I have 1 mole of the C2H6. 2 times 2 gives me 4. Question 10 is another dimensional analysis. We're looking for which quantity is equivalent to 39 grams of LiF. So we need to know how many moles. But first we're going to have to find the molar mass of LiF for our conversion factor. We have lithium, which is about 7, and fluorine, which is about 19. That gives us 26 grams per mole for LiF. That's the conversion factor we're going to use. So how many moles are in 39 grams of LiF? Grams go on the bottom to cancel grams. Moles will go on the top. We have 26 grams for every 1 mole. We're going to have to use division. So we have 39 divided by 26. And that gives us 1.5 moles. 1.5 moles. Our choice is D. Question 11. It's another type of reaction. So if we look at types of reactions, we have A plus B, which gives us AB, and this is synthesis. We have AB breaking down to A plus B. This is decomposition. We have AB plus C, giving us AC plus B. This is single replacement. We have AB plus CD, giving us AD plus BC. This is a double replacement. And I'm not going to even do composition right now. If we look at this reaction, I have this all by itself, so it's A. And this is BC. Okay? And it switches places. A takes the place of the B. So this must be a single replacement, right? We have AC plus B. This is a single replacement. We see this is alone by itself, and it's replacing the first element in the compound. Question 12. What is the total number of moles of atoms represented by the formula? Okay, so we're going to have to figure out the total number of atoms, right? And that's going to be our moles of atoms. Aluminum is 1, and we have this subscript of 3. So 3 gets multiplied into all these things. I have 3 times 2, that's 6. 3 times 3 is 9. 3 times 2 is 6. And we have the 1 from the aluminum that we're not going to forget about. So this is 22 atoms in this compound, right? 1 plus 6, 7, and 9, and 6 gives us the 22 that we need. Question number 13. Given the reaction, what is the total number of moles of NH3 produced when 10 moles of H2 reacts completely with N2? Okay, so let's first set up our molar ratios. We have 1 mole of N2. We have 3 moles of H2. We have 2 moles of NH3. And now let's use dimensional analysis to solve this. How many moles of NH3 is equal to 10 moles of H2? Okay, that's our setup. We're going to use the molar ratio to find the conversion factor, as our conversion factor. We're looking for moles of NH3. That's what we're looking for, and we have moles of H2 on the bottom so that they can cancel. Okay, going back to the balanced equation, I see that I have 3 moles of H2 and I have 2 moles of NH3. So we have everything on the top getting multiplied. 10 times 2 is 20, and we divide by what's on the bottom. So 20 divided by 3 gives us 6.6666, so that's 6.7. Choice A. Question 14. Given the word equation, what type of chemical reaction is represented by the equation? Okay, so we have to know some things here. We have to know how we can take this equation given to us in words and write it in a chemical equation, and then identify what type of reaction is taking place. So sodium chlorate, chlorate is a polyatomic ion, and sodium is Na, NaClO3 is sodium chlorate, and we're going to have NaCl plus O2. Okay, so this is a decomposition reaction because we start with a compound, and the compound is broken down into smaller products. In this case, sodium chloride and oxygen. Question 15 is a short response question. It gives us a reading that I always tell you guys don't even bother reading. I advise you to look through, scan the words in order to find what it is they're looking for. That usually comes at the end, and then you can go back into the reading and pick out the information that you're going to need. So I'm going to shoot straight to this part right here. Determine the number of moles of O2 required to completely react with 28 moles of CO during a reaction. So the reaction is right up here. We have 2CO plus O2 yielding 2CO2. That's the balanced equation. I'm going to write the molar ratios. I have 2 moles of CO. I have 1 mole of O2. I have 2 moles of CO2. And now I'm going to set up a dimensional analysis problem and see if I have enough information to solve what I'm being asked. So how many moles of O2 equal 28 moles of CO? Okay? I'm going to use the molar ratios as my conversion factor. Moles of CO go on the bottom so I can cancel. And on top, I'm going to put the moles of O2, which is what I need. Looking at the balanced equation, I see I have 2 moles of CO for every 1 mole of O2. And we have 28 divided by 2, which is 14. And don't forget your unit. Your unit is moles. 14 moles of O2. This is your answer. Okay, the next question is another short response with a brief reading. I'm just going to go ahead and jump right to the question. Balance the equation for the reaction. Okay, so I have a chemical reaction that's given to me, and it's not balanced, and I'm going to go ahead and balance that equation. I like to just move back and forth between the different sides of the equation, the reactants and the products, and keep checking it until I have what it is I need. So I could see right away that I'm not balanced. I have 2 nitrogens on this side and only 1 nitrogen over here. So right away I'm going to put a coefficient of 2 in front of the NH3 to try to balance out my nitrogens. Now I have 2 nitrogens on the reactant side and 2 nitrogens in the product side. The next thing I notice is that I have 3 over here and 2 over here, but now that I put this coefficient of 2, that's telling me 2 times 3, I actually have 6 hydrogens over here and only 2 on this side. So I am going to need to make the hydrogen on the product side equal 6, and I'm going to do that by putting a coefficient of 3. Now I have 6 hydrogen on the reactant side and 6 hydrogen on the product side. Okay, so far so good. Now I see that I have I see that I have a problem, is what I see. I see that I have 3 oxygen, which is an odd number, and that's going to make my life difficult. Oxygen, O2, tends to make lives difficult. There's a little trick to this. If I take all of the coefficients that I have, I'm not going to touch this oxygen. I'm going to do something first. What I'm going to do is I'm going to take all of the coefficients I have, not oxygen though. Oxygen I'm leaving alone. I'm going to take all of these coefficients and I'm going to multiply them by 2. Okay? I'm going to multiply them by 2. That means that I'm going to erase. I have for NH3, I have 2. So 2 times 2 will become 4. And I told you I'm not touching oxygen, I'm leaving it alone. N2 has a coefficient of 1. We're going to put 2. 1 times 2 is 2. Water has a coefficient of 3. I'm going to multiply it by 2. 3 times 2 gives me 6. Okay. So now I have these numbers here. And that's going to make my oxygen even. So let's check what we have. We have 4 nitrogen over here, and I have 4 nitrogen over here. My nitrogen is good. I have 4 times 3. That's 12 hydrogens over here, and 6 times 2. That's 12 hydrogens on the product side. Now I can balance my oxygens. Now I'm finally going to go back to my oxygens. I have 6 times 1. I have 6 oxygen. I need 6 oxygen. I have 2. So I put a coefficient of 3, and that gives me the 6 that I need. So the balanced equation is 4NH3 plus 3O2, yielding 2N2 plus 6H2O. Those are tricky. Oxygen tends to be tricky. Okay. Next question's another reading. I'm just going to see what they want, and then I'll go back and I'll pick out the information that I need in order to solve the problem. So it wants a numerical setup for calculating the number of moles in a sample of CaCO3. Okay, so they're only asking for a setup. That means I don't have to calculate. I just need to show a setup. And I'm calculating the number of moles. So let's see. I have, what did they give me? CaCO3 has a mass of 42.2 grams, and calcium carbonate, that's the name of this compound, calcium carbonate, it has a molar mass of 100 grams per mole. Okay. It wants to know the number of moles. So how many moles are in, and they want to know how many moles are in 42.2 grams, right? How many moles in the sample? It tells me the sample has a mass of 42.2 grams. So that's the question. That's the setup. That's what we're looking for. The conversion factor that we're going to use is the molar mass of 100 grams per mole. So on the bottom, need to go grams so that grams can cancel grams. On the top, we'll go moles. I have 100 grams for every 1 mole, right? So that's all I need to do. This is the setup. I don't need to calculate. That's all I'm going to put on the test question. Okay, question 18. Base your answer to the following question on the information below. Okay, so I'm going to go straight to the question. Determine the mass of CO2 produced when 9 grams of glucose reacts completely with 9.6 grams of oxygen to produce 5.4 grams of water. Okay, this is a conservation of mass. Conservation. That tells us that the mass of the reactants must be equal to the mass of the products. Now, we have to read this question to figure out. We might not know what glucose is. We might not know these things. So we're going to look at the language used in the question. CO2 is produced. That's what we're looking for. The CO2 produced. That's the unknown. 9 grams of glucose completely reacts. If glucose reacts, that means it has to be a reactant. So glucose is over here, it's a reactant, and I have 9 grams of it. And it reacts to produce, so my products will be 5.4 grams of water. X is what I'm looking for. 9.6 grams of oxygen is here. Okay, so we're going to set up an equation, and we're going to use the arrow like an equal sign. Here's the equation. I have, let's go down here and maybe use a different color. I'm going to rewrite it. 9 plus 96 is equal to X plus 5.4. This is the equation rewritten. We're going to combine like terms, and we're going to solve this algebraically. 9 plus 96 gives us 105, and it's equal to X plus 5.4. Going to subtract 5.4 from both sides. This side will cancel. And this is going to give us an answer of 105 minus 5.4, 99.6 is equal to X. Don't forget the unit, the mass, determine the mass. So 99.6 grams. And that's the answer. Okay, we are almost done. We're on question 19. There's 25 questions. This question is asking us to rewrite the following reaction as a chemical equation. So we're given words, and we have to remember a few things from the bonding unit in order to successfully write this equation. So we have calcium, and it reacts with manganese 3 chloride. Okay, so this tells me, I have calcium, and it's going to react with the manganese 3 chloride. The 3 tells me that my manganese has a charge of +3. And I have it bonded to, it says chloride, that means it's chlorine. And I use the oxidation number for chlorine, which is -1, in order to figure out how this metal and non-metal will bond together. So Mn +3 Cl -1. I need these charges to cancel to 0. I need +3 and I need -3 somehow. I need them to cancel out. So that means that I can crisscross, right? The quick shortcut would tell me that I have Mn1Cl3. But I could also look at this and I could see that if I have a charge of +3 over here, I'm going to need 3 of the chlorine for 3 times -1 to get me the -3 that I need to cancel out to 0. So the compound is going to be MnCl3, and this is manganese 3 chloride. Let's see what else we have. Okay. And it produces calcium chloride and manganese. Okay. So calcium chloride. Calcium has a charge of +2. And chlorine, again, is -1. That means I need 2 chlorines in order to get my charges to cancel. +2 over here and -2 over here. So that means this has to be CaCl2. And I also have manganese. This is my equation. You must remember bonding. You can't forget how to bond. Okay, the next part, balance your equation. Balance it. Okay, so I'm going to go back and forth. I have 3 chlorine over here and 2 chlorine over here. I need a common multiple to get 3 and 2 to be the same. I know my common multiple is 6. So I'm going to put a 3 as a coefficient over here. 3 times 2 is 6. And I'm going to put a coefficient of 2 over here because 2 times 3 is 6. Now let's see what we have. We have 3 calciums over here now. So I'm going to put a 3 in front of this calcium. And I have 2 magnesiums over here. I'm going to put a 2 coefficient over here. So this is the balanced equation. I'm balanced now. I have 3 Ca plus 2 MnCl3 yields 3 CaCl2 plus 2 Mn. Okay, what type of reaction is this? For question 21, what type of reaction is this? Well, this is a single replacement. We have calcium replacing manganese in this equation. So this is single replacement. 23. A sample of sodium azide, NaN3, is being used. Okay, let's see what we need. We have 5 moles of this. Question is how many grams of this? It wants a numerical setup and the answer and the unit, okay? So these are the things we need. We have a decomposition reaction. Doesn't matter. We're looking for how many grams of NaN3 are equal to 5 moles. We are going to need a molar mass. We're going to need a molar mass for NaN3 to use for our conversion factor. We have Na, which is 23, and we have 3 nitrogens, which is 14 times 3. So that is going to give us a molar mass of 65 grams per mole. And now we can use this as our conversion factor. We have moles on the bottom to cancel moles up here. We have grams on the top. We have 65 grams for every 1 mole. And now we can calculate 5 times 65. This is going to give us 325 grams. Don't forget the unit. Okay. 24. We have what is the total number of moles of O2 that must react completely with 8 moles of Al to form the product. I'm going to go in and put in our molar ratios. We have 4 moles of Al, 3 moles of O2, 2 moles of product. Okay. Dimensional analysis. I love it. I need to find how many moles of O2 is equal to 8 moles of Al. Molar ratios as my conversion factor. Moles of Al will go on the bottom to cancel the moles of Al up here. I need to find moles of O2. Okay, so molar ratios from the equation tell me that I have 4 moles of Al and 3 moles of O2. This tells me 8 times 3 is 24. 24 divided by 4 is 6 moles. That's the answer to 24. Finally, we're on the last question. Okay, this last question is another reading. I'm going to skip right ahead to the question contained within this. It's telling me to explain why CD would be above NI if placed on table J. So this question is merely testing to see if we know how to read table J and what it's about. So table J is the activity series, and it gives us a list of metals on the left-hand side. And the metals that are higher up are most active or more active or reactive than the metals that are below it. And they will replace them. A more active metal can replace an element that's placed below it. So these are less active, less reactive. And it's telling us CD, would be above NI. And why would that be? So our answer would simply be CD is more active or reactive, either word is fine, is more reactive than NI. That's all we have to put. Simple. So that completes the practice test. I hope the video was helpful. I'd be happy to answer any specific questions you have about any number of these questions. I'll go into further detail if necessary. Just let me know so I can do that for you. And I hope this was okay.